So if we look at the glass of ice water, it's very strange that ice floats. Usually a solid is heavier than its liquid because it's more dense, and it should actually sink to the bottom. But even more stranger is that at the bottom of the glass it's 4 degrees Celsius. And you will find 4 degrees Celsius at the bottom of all lakes and oceans because water is heaviest there. And as you cool a liquid down, it shrinks. But water, as you cool it beyond 4 degrees, it actually expands. And so we have been developing techniques to be able to study water in the supercooled regime. Supercooled means that you measure or you study water below the melting point, where ice would be the thermodynamic stable form. If you have a very clean water, you can supercool it down to -20, in some cases even -30. But at that point, ice starts to form very fast. So this strangeness of water seems to be accelerated, and this acceleration, if you fit them with a mathematical function, they seem to lead to a catastrophe around -45 degrees Celsius. And it's been a big question what actually is happening there. An hypothesis is that under certain conditions, at certain higher pressure and very low temperature, water could then actually develop into 2 macroscopic liquids. Very unique, hardly no other substance can do this. It will mean that this fluctuation will suddenly be so large that you actually form macroscopic phases. And these phases would have a density difference of almost 20%. If we would have a glass of water, it will look like oil and water here, as you can see. One is much heavier, it's 20% heavier than the other one, and you will have a phase boundary in between it. Water fluctuates between these 2 different structures, and what we found as we cool water down, this fluctuation increases, and they reach a maximum at -44 Celsius, a very low temperature that we actually could study it in the liquid form. And it doesn't go, this fluctuation, to infinity as you cool it. It doesn't mean either that it suddenly stops. It reaches the maximum, and beyond the maximum it decreases again at lower temperature. We could go all the way down to -47 degrees Celsius. And we therefore see now the trace to the existence of a critical point. And the most famous critical point water has is between its liquid and the gas. That's called the first critical point. Second critical point, then, it will be between these 2 liquid phases. Never seen in any system. And it will scatter light. And therefore, at the critical point, if we will look at water at that point, it will look milky. We have seen now this maximum, and this maximum points to, as a trace to this critical point, and also to that water can exist at 2 liquids. So it's unified our understanding, so to speak, of it. And since these fluctuations are the things that make water strange, also for our existence, this critical point, in some sense, is the origin of this strangeness. And we have, in this discovery, found a trace.